Today I will my topic would focus mainly on manufacturing post COVID. The reason why I'm calling this as post COVID is even in the US there is a lot of discussion about how to bring back manufacturing back to America, and same thing we are also hearing from India and many other countries. Um, so there is this drive to bring manufacturing and product uh, development and design in-house, or in within source everything within the country, and this is the direction that most of the countries are now trying to go. So I want to talk about this, and COVID has kind of forced this on countries which were not doing it. Everybody was happy to buy from China so far. So this has kind of forced everybody to rethink and redo the business. So this is definitely a COVID induced change. I don't know how far it will be successful or not. Once everything becomes normal, people will also tend to go back to their old habits. So we have to see, if this kind of bears fruit, or if we will forget everything and go back. Um, so let me start my presentation. If any of you have any questions, please stop me and ask me a question. I will try to, give you more details. I don't want this to be like a monologue where I'm just talking for so many minutes. Anytime, if you want to know more, or if you have questions, if you want to contradict, you're welcome. Okay. Uh, the outline for my presentation today is I'll give a brief introduction about what I am doing, and what are some of the projects I worked on, so you have a background of where I'm coming from. And I will talk about current status of manufacturing and product development, and I will also talk about what are the new things that are coming up. Specifically, additive manufacturing and 3D printing are 3D, both are same. That's the main focus area I'm working on for last 3 years now, and I will talk about it in detail, and I will explain, why this is unique, and what are the advantages it brings us, and what are the typical applications for 3D printing, and what are the looking ahead, what are the opportunities that we can look for in this field. Okay. um, so yes, I'm a mechanical engineer, and I mainly I was fortunate enough to to be mainly working on new product development for most of my 20 years of career, and I'm quite happy to do my job. And sometimes I feel people pay me for which I would have just probably worked for free, because it's sometimes it's enjoyable work. um, so mainly I focus on CAD, and CAE is a computer aided engineering. It's a broad field, and then testing the product, and then validating. I will explain a little bit more in detail. And my main background is in aerospace. I have good amount of experience also in automotive world, and some unique applications in biomechanical sports equipments and so on. But overall, the my focus area is to make products lightweight. Okay. Why it is important? Because in the beginning in aerospace, it's all about weight. The lighter the aircraft, the more fuel efficient it is. The more performing it is, the cheaper it is to fly, and so on. So weight is enemy of aircrafts, right? But in automotive, people didn't care so much about weight until electric vehicles became the new automotive um, uh, products. So for electric vehicles, especially, weight is the enemy of electric powertrains. So your battery has to be bigger, your electric motor has to will become bigger, cost will go up, and your charging time will increase, and so on. So if you carry 100 kilograms of unnecessary weight in the car, that leads to probably another 100 kilograms of additional weight, because your battery became bigger, your motor became bigger, your controller dissipates more, and so on and so forth. Okay. So because of this, there is a lot of emphasis on making structures lightweight. And biomechanical is also same story. Sports equipment is also same story, because in sports, if you want to be like really fast, um, for example in racing, your vehicle has to be really lightweight and very high performance. Same for even say, if even in cricket, if you are carrying lightweight equipments, lightweight helmet, for example, right, it's much more comfortable for the players. So things like that. So making things lightweight is definitely a big focus in product development these days, especially handhelds and um, automotive and anything that gets transported. And I personally, I am more attached to clean and green technologies. I like to learn new things that are reducing the pollution, uh, trying to make pollution zero, carbon footprint, and so on. That's my pet or favorite field to work on. So that's a brief introduction. So I was again fortunate enough to work on multiple small aircraft projects. Two of them were vertical takeoff and landing aircrafts. This is a new field, and right now there are like at least 20-30 companies around the world that are working on vertical takeoff and landing. Just a brief introduction for those who don't know what this is vertical takeoff and landing is nothing but like a helicopter. It can it takes off vertically. It doesn't need any runway. But now lot of companies are thinking of how to use this as a taxi type of service within cities, because of the traffic congestion. A lot of time you spend on road going from point A to point B. In the immediate future, in maybe next 2-3 years, you will start to see small aircrafts, just like helicopters, basically acting as a taxi service. So Uber, which you guys all know, they're giving a really big push to this idea. This is not a new idea. You probably have heard of flying cars, all along, right? So flying car was an idea of making cars as a taxi service. But now there is a bigger push towards this, because for example, Uber can have maybe in Bangalore 100 different places where these can land. And when you call Uber, Uber will take you from your home to they are calling this as a airpod. So you can, the Uber car will drop you to the airpod. From airpod, you get on it's called VTOL, vertical takeoff and landing aircrafts. You'll get onto that. And from that airpod, it will drop you to the nearest airport near to your destination. From there will be another car waiting, and then that will take you to your destination. So these things are happening already. They are not they are in the testing phase. So in few years, mostly the reason why it has not become reality yet is the regulations are not in place. Like if you want to start this service in Bangalore, government don't even have a way to give you a license. Okay, so this is the bottleneck right now. But otherwise, the aircrafts are designed, they are ready, they are tested, everything works fine. Companies are also have enough money to deploy these kind of solutions. Anyway, so coming back to my work, I was fortunate to be involved in this at least three of these type of aircrafts. My main work was again looking at the aircraft structure, like fuselage, landing gear, and wing, tail, and so on, and try to make it as light as possible. So electric propulsion, electric powertrain or electric propulsion, which is nothing but a battery pack, and motor, electric motor, and motor controller. They are the key for a lot of these new innovations that are happening in aircrafts as well as in high performance automotive world. You might have heard of Tesla, and a lot of other companies now also have developed electric and hybrid vehicles. So I was fortunate to be part of some projects in those. And in biomechanical and sports equipment, as I mentioned earlier, there is really lot of innovation going on. I will touch upon those a little bit. Again, lightweight and high performance is the key, and that's where I found a lot of my opportunities to do projects, find work, get paid, um, and so on. Um, before I go back to my main topic for today, which is manufacturing, and in manufacturing, 3D printing or additive manufacturing. Um, just I, I will just show you maybe some of the projects. That way, you not this one second. You just get an idea. So this was one of the uh, old aircraft. It was made of metallic aircraft before, and they wanted to convert this to lightweight, carbon fiber composite material aircraft. So I handled not the fuselage, but I mainly handled the rear of the aircraft and also the wings. So this was the old aircraft, and this is the new aircraft, and this is the one that I worked on. The old aircraft was like more than 30-40 years old. So this is the new generation. And what I mainly do is I create virtual models for these structures, and we apply loads. We look at the how the stresses are developed, what are the deformation, whether it will survive, whether it will break, and where we are unnecessarily using weight, so that we can take out that parasitic weight, and so on. So just the reason I'm trying to show you is when I was getting ready to do our engineering final year engineering project in 1996. So we had one professor, Professor Y.T. Krishnagowda, who did his master's or maybe PhD from IIT Madras, and then he came back to our college, and he came back with this knowledge of finite element analysis, and using computers to solve structural problems and so on. And nobody knew, even in our college, no one knew what this is. And he introduced that to all of us, and fortunately 6 of us were assigned to work under him as a project guide. And he said, why don't you guys look at this new technology, and you can use computer program to solve your problems. And we were all fascinated by that, and I really enjoyed doing that. And I don't know if YT Krishnagowda realized what he was, or at least how he was paving way for us to build our own career on that. It probably he was not even thought about it. But um, at least for 2 of us out of 6, we really enjoyed doing it. And I personally just decided, this is what I want to do for foreseeable future. And after completing the engineering, I also found job. There were not many finite element related work at the time, but I was lucky to get a job in Bangalore. And I continued to work on finite element analysis and then optimization, and then also learned about how to build prototypes and test and validate and so on. So what you are doing in the college, you may not realize it, but sometimes it's really important. You just introduce something unique to your students, and they will pick it up. Maybe you won't know, but you'll see the result after several years. Okay, so I want everybody to to be YT Krishna Gowda, in that way. And I still keep in touch with him, and he's happy to see, some of the work I have done, because he also feels, there is some contribution from his side. So I'll quickly go through some of these projects. So the basic idea is you build a virtual model in a computer and solve all your design related challenges in the computer. You optimize it, you try to reduce weight, you do all kinds of tests with respect to, say, thermal or CFD, or like fluid flow. You can do structural, linear, non-linear, fatigue and durability, buckling, and so on. So there are like whole array of tests that you have to do, but you can do everything in a virtual world. You can optimize, fine tune your design, and then let the team build the prototype. That way it is faster, it is cheaper, it's more accurate, and also it gives you an edge. If you really do a good job, it's hard for competitors to catch up with you. So there is a lot of advantage to adopt CAD and CAE and optimization as a toolkit for engineering design. Anyway, I will not go into much of these details. So this was one of the vertical takeoff and landing aircraft that I worked on. I was mainly responsible for the analysis of the wing and the
Sir,
landing gear.
probably, yeah, sorry to interrupt.
Mm-hmm.
You are presenting any slides or yet to start presenting
No,
slides?
I am
Slides
presenting
are
my
not
slides.
visible.
Oh,
No,
okay,
no,
okay,
it's
okay.
not
Sorry,
visible.
sorry.
Sorry.
Okay. No, no. Yeah, that's good that you told me. Uh,
Probably a few times you told like this, no? Then I felt that you are
correct, correct,
probably
correct.
not presenting.
It
Okay.
was visible to us, sir. By pinning to him, we can see that.
Oh, okay? Are you seeing a picture of aircraft?
Yeah, yes, sir. Now it is visible to us.
Okay. Okay. Let me know. Can you see the presentation now?
Yes, we can see that.
Okay. Okay. Fine. So yeah, I'll quickly show. So this was the old aircraft that I was talking about, and this is the new aircraft. This is not a vertical takeoff landing. This is a fixed wing regular aircraft. Um, this design is the vertical takeoff and landing aircraft. Okay. And I was responsible for mainly the wing and the landing gears for this project, structural analysis, and support them with weight optimization. So this is the actual prototype that we built, and we did the testing. And I was also responsible for the electric motors. So this is an electric aircraft, by the way. There is a unique advantage of electric vehicles when you want to take off vertically and land, because your motor also works as a control surface. So you don't need a new control surface. You can use the motors itself as maneuvering, control surfaces. So this is the design for the electric aircraft, electric motor, which is embedded in the propeller itself. So this flew successfully in 2015, early 2015, and we did a lot of engineering work for this. This is probably the first aircraft that flew, electric aircraft that took off vertically and landed and did all the testing successfully. This was done in California, Bay Area. This is the actual aircraft that was finally built and test flown. So you can see it flying. This is the main landing gear, and this is the test setup. So I have a couple of pictures of this. This is the front nose landing gear. Again, everything was optimized, and this is the wing design. So this is another view of the wing. This is the second generation aircraft, the same aircraft, but with some design changes. So you can see the propeller embedded, electric motor embedded propellers here. So this is the CAD model for that, and this is how it looks inside. This is an electric motor with um, the whole assembly. And then this is the actual motor that was built, um, and we also tested that. So in the lab, it was tested to make sure the performance and weight and all other aspects are met. So that was one of the project, and this is another project where I worked on. In this, I'm showing the propeller, which has a variable pitch propeller, again with an electric motor in the back. And we also did the testing of the propellers at the test lab. This is one of the Formula E race car. This is another 8-seater aircraft. This is what Arvind was talking about. So in 2012, Adidas, I was a consultant again for Adidas at the time. So we designed a new shoe sole for sprinters, 100-meter and 200-meter sprinters. This was owned by all the Adidas sponsored sprinters. Unfortunately, Usain Bolt, he's really fast. It doesn't matter which shoe he wears, and he won the race because he's a miracle, right? Miracle runner. So, and he was wearing Puma, but our guys also did pretty well in the race. I think they came third. One of the guy came third in this. Again, there was a lot of engineering work that went behind this sole design. What you see is like a pattern. It's not a pattern that somebody sketched. There is a lot of engineering work behind all this design and all the structure and everything. But what I'm trying to show is how we can use engineering and actually make a huge difference in real life. Okay, so I just switched to my other presentation. Are you seeing my new slide where I'm saying, okay, manufacturing, why China is dominating?
Yeah,
It's
it is visible, sir.
Okay,
visible.
okay, good. So yeah, that's the introduction part. I'm back to my main presentation today. Um, okay, so again, COVID has created this opportunity for countries and companies to think about where they are sourcing their products, how they are manufacturing, and what they can do in going forward. Especially in the US, there is a big push to bring manufacturing back to America, because right now I think maybe 70-80% of manufacturing is done outside, and much of this is coming from China. First, let's understand why China is dominating, and we can then compare, okay, where they have advantage, where they can change, how this can be shifted out of China for various reasons. There is no politics in this. I don't believe in that, but there are reasons why it has to be shifted out, which would naturally happen. Okay. One is the biggest, even though we think, China manufacturing is cheap, it is not cheap for no reason. Okay. It's not like somebody is giving you taking a loss. They are making a profit too. So it is cheap because they have set up a huge manufacturing ecosystem. When I say ecosystem, they have access to raw material. They have invested huge amount of money in, say, Australia, in Asia, in Africa, in South America, everywhere, all parts of the world. They have invested a lot of money. They have taken ownership of the mines and raw material production units and so on. And based on that, they have also built a huge shipping industry. Okay, they have built huge ports. They have built ports in Africa, in South America, in in Pakistan, for example, in Sri Lanka, and so on. So they not only have set up huge factories to manufacture, but they have set up huge infrastructure which will support that in terms of mining, in terms of transportation, in terms of managing the logistics, clearing from port. For example, in India, if you have to clear a shipping, which we do once in a while, sometimes it takes 2-3 months because nobody is answering why they have held up the shipment. But in China, you can pretty much in 2 days you can load the shipment, and it's already off of the port. So they have already streamlined a lot of this bottlenecks, and they have put in place this system which is a huge infrastructure which supports all these activities, and that's one of the reason why it is cheap. Okay. And of course, they have invested heavily on raw material. They have, for many years, they have been going around and purchasing all the mines and all the resources. And they have also built huge mm, electricity production units. They have invested heavily in solar, wind, and also in coal powered plants and whatnot, huge dams. I'm not supporting that, but I'm just stating the reason why they have built what they have built. Okay, we don't have to copy them. We don't have to bring all the negatives that also come with building, say, these kind of huge dams and destroying the ecology and things like that. But I'm just trying to uh, illustrate what they have done to get this upper hand in the world manufacturing field. Okay. And also they have legacy manufacturing knowledge. And today, if you ask them to build something, there are 10 companies in China who can build the same thing, and you can go and get that manufactured. But we cannot say the same thing to say in United States or in India or many part of the world. So just because they already have a setup and there are companies which are already building similar products, they can easily build it. Just to give you an example, when India wants to build Sukhoi aircraft, we only have HAL, right? So they have to come to HAL. There is no other option like that. So just because of the existing infrastructure and existing system, they keep winning new projects. They keep producing more. And again, the pollution is, the norms in China are not very strictly imposed. The companies are can pollute, which is very strictly controlled in most of the Western countries. And India also has a fairly good pollution norms. So this is one of the reason why many companies don't want to deal with the pollution, and they will say, okay, as long as we are getting what we want, we don't care what China is doing. This hands off approach is also one of the reason. And government policies and government support also plays a huge role. This is like an invisible hand. While, say, in my own personal experience, we face so much trouble getting permits or getting shipments, paying taxes and so on, um, and dealing with a lot of red tape. In China, it's all streamlined. In fact, if you export a part, the government will give you tax break. So they will send all the taxes you had paid. They will put the money back to your account automatically the moment you raised a bill, for export. So things like that. A lot of things that help the business. And they also implemented a huge like government driven plans for like 10 years, 10, 20 years, 25 years, and so on. Right now they are implementing China 2025 vision. You can go Google and look up what they want to do under that plan, and they are actually meeting all the targets they had put forth maybe 25 years ago. And 25 years ago they said, okay, these are the things we will do for 25 years, and they are pretty much achieved all of that. when you have time, please go take a look at it. So what I'm trying to say here is, when you are getting like a cell phone, or some, even maybe a shoes or whatever, if it was manufactured in China, it is not just one single factory that's delivering that goods. There is a huge infrastructure, there is huge planning and so on that has already went into establishing these facilities, because of which they are able to take advantage of all the infrastructure and ecosystem that they have built, and they are able to deliver products at really cheap price, but reasonable quality. Their quality is actually pretty good. Apple manufacture all their phones in China, so they can deliver world-class products. There is no question. It's the price, whatever price you are willing to pay, they will match the quality with the price. Okay, and as this picture illustrates, they have built like such a massive infrastructure for manufacturing. It's hard to replicate. Even if India wants to do it tomorrow, they cannot. They need at least 10 years to even to come up to this kind of size and capabilities. So in my personal opinion, we cannot, or the rest of the world cannot beat China in this game. Okay, but there are other things that are now happening which take away this advantage that China has built, and is opening new ways of doing manufacturing, which is what I'm going to talk about. Okay. Specifically, there are so many different technologies that are evolving, which we can take advantage of and try to do manufacturing in-house. But 3D printing is definitely one of the key technology for manufacturing going forward. And that's what I will present to you for the rest of my presentation. 3D printing, I'm not sure how many of you are familiar with it. Maybe you have heard of it. Basically, it's actually literally a printer which prints a part for you. It could be plastic, ceramic, metal, super alloys, and so on. I'm mainly working on metallic 3D printing parts and designs for last like close to 3 years. So when compared to big factory like this, which requires like hundreds of crores of investment, with a 3D printer, which looks something like this, you can pretty much print the whole part. And you can imagine all of a sudden you shifted the manufacturing requirement and the infrastructure and the investment that goes into building such a huge factory and manpower and so on. So you can, for most of the parts, you can change the game by just adapting to a new technology. Okay, and this is where a lot of opportunity exists to not copy what China is doing and not copy how much money they have invested and trash the whole ecology. But you can be smart and just leap forward and adapt a new technology where you don't have to. You can negate all the negatives that are there in an existing system and probably start with a new cleaner and less expensive technology, which gives you an advantage. Okay, so what this does is it takes a powder. I'm only focusing on metallic, but there is plastic, ceramics, and you name it. So everything nowadays is thought of as how can I 3D print this? So, but I will only talk about automotive and aerospace related because that's the field I work in. So if stop me if you want to know more about 3D printing. Otherwise I'll continue. Okay. In the sense, if you're not familiar with what 3D printing is, and if you want to know a little more introduction to this, then stop me here. Okay. What this does, what the advantage that 3D printing gives us is, one is it opens up new possibilities for product design. I will explain all those things, in my presentation. It also helps us, as far as I'm concerned, lightweight and high performance, high temperature type of applications. And you can also have choice of material. For example, um, you can choose in the same product, you can choose to have titanium, aluminum, and steel, and ceramic, and plastic. Okay. And you can put together all of these material in one product and make a high performance product out of it. And it also provides a flexibility of manufacturing. For example, let me show you, I have one video. Um, one second. I think I have to exit here. Okay, so are you able to see the video I'm playing?
Yes, sir, it's visible.
Okay. So what I'm showing you is a stamping unit for stamping a car side panel. So you can see this progressively, it's getting stamped in a die, and then it gets trimmed and so on. So it goes through several stations before the car side, one side panel is ready. Okay, and for that to happen, let me show you. So this is a kind of a huge factory that you need. Okay, yeah, you can imagine the size of the factory and the toolings. This is just for one part I'm showing you, but there are hundreds of such parts that are required um, for a car body panel. So you can see all these progressive stations. So it will be stamped in one station and then go to the second station, third station, fourth, so on and so forth. So you can imagine how much money that goes into building this factory, how much money you have to spend on building these tools, and millions and millions of dollars. But if the car kind of did not succeed, people didn't like it, they have to discontinue. But all the investment that they made to build this huge dies, and all the millions of dollars they spent on building this tool itself, is all is gone waste. There's a huge loss associated with it. Not only that, just to have a one car prototype built, you need to spend years or maybe months and years of tooling, and then you produce a part. And if the part doesn't come out well, if it has problems with it, quality issues, or folding and tearing off and whatnot, then you have to go back and redo your tooling and readjust and so on. So this puts you not only investment wise at a very big disadvantage, it's also time that you have to invest, right? You have to plan ahead, maybe years in advance. So car projects typically take 4 years. So from concept to actually releasing, it's a 4-year cycle. Some companies have shrunk it to maybe 3 or 2.5, but still it's a lot of time, lot of money spent. And you can imagine just for one part how much effort or resources go in. So what I'm trying to show is only companies which can invest in this kind of infrastructure can do this job. But as you saw, this facility is only meant for building car panels, right? It cannot produce anything else. If you want to produce something else tomorrow, then you have to tear down everything and then retool and invest a lot of time, lot of money, tooling, and so on. So typically no company does that. They keep producing the same panels over and over and over again. You can almost think of it like a rigid infrastructure which can only do what it is supposed to do. But in case of additive manufacturing, what happens is you have this flexibility. You can just print one part, you can print 10 parts. You can change, in between. You can basically, it's like printing. You have a printer at home. You can pretty much print whatever you want, right? It will print on a sheet of paper. It's exactly like this. Whatever you give a command to print, it will print. So that flexibility is there. So during COVID, a lot of companies which were involved in 3D printing, all of a sudden, their regular production was not required because, people are not going out, business are have shut down and so on. But medical equipment became a huge demand. So all of them just stopped whatever they were printing or producing, and they shifted to whatever is the emergency production. Okay. So this kind of flexibility inherently comes with this technology now. And you can also customize what you want, in the sense, if, for example, if you're printing any biomedical implant, everything can be customized for you as a patient, and it can be very unique in design, very unique in structure, weight, and so on. This is a huge advantage when you have to produce one-off products, which you cannot even think of in other kind of manufacturing setup. And you can change your response based on the demand. And there is also a lot of efficiency and cost advantage that the 3D printing provides you when compared to a traditional manufacturing setup. As I said, the key advantage is you completely eliminate tooling cost. You completely eliminate the time that it requires, that you have to spend to first make the tools and then tryouts, and then rectifying all the errors that you get in your product, rework the tooling, and so on. All that is completely eliminated, and you don't need huge infrastructure, huge plants, huge machineries, and trained skilled manpower, and so on. And you also don't really need any ecosystem. You don't. So typically, when I say ecosystem, um, uh, even though there is one company that manufactures a final product, it was cast in some other factory, and it was machined in some other factory. It was post processed in some other factory, and then it was maybe given a final shape in some other factory, and so on. So it goes through so many different factories or systems that all can be completely eliminated with a 3D printed part. Okay. And right now the cost is quite high, but it's coming down very fast, and it will become competitive in coming years. This is guaranteed. And right now, the cost key drivers for adopting this technology is the cost of the machine itself, and then the material cost, which is the powder cost, and simply the cost of adaptation is quite high. Like, where do you find people who can 3D print? What is the skill level? How can they design, and so on? And right now, size is also another mm, limitation, because the printers come with a limited volume within which you can print your parts. So if you want to produce huge parts, the printers are not ready yet. In the near future, it will come, but right now the printer size are quite limited. So what are the applications? So why in the context of China, why did I mention this? The reason I'm mentioning 3D printing as a new manufacturing opportunity is we don't need to have such a huge infrastructure, huge ecosystem, factories, and so on. This can be turned around, and a small printer in a small shop can actually do the same job that the big factory is doing, and that's where the opportunity lies. So we can bring some of this manufacturing back, say to US or to India, or whichever country is considering it, and they can start with this, and they don't have to go for the old big factory type of technology, but they can go with this nimble 3D printing, and first look at what are the parts they can produce with this 3D printing, right? So that's an opportunity for countries now. And what are the typical applications that low hanging fruit, so to speak, for 3D printing is one is definitely product development and validation. As I mentioned, when we build new products, there is a lot of trial, there is a lot of iterative design, back and forth, testing and validation, and new design iteration that has to happen. All that can be very efficiently executed with the 3D printed parts. You don't have to have two. You don't have to build tools. You don't have to invest a lot of money. You can use a 3D printer to quickly print your design and test it and validate it and then iterate that way. And also, there is a lot of customization requirement, especially in biomechanical, biomedical, and even in aerospace. So 3D printers can be very efficient for customization. And this is a big opportunity or big plus for people like me who are mostly involved in product design. So when a new product is thought of and is being designed, how fast we can realize it, how fast we can complete the project and deliver, there is a huge importance for that. Okay, because there are always other competitors which are also trying the same thing, so you want to beat the competition, and this is where you can win. Many times within one day, like if you finalize the design today, tomorrow you'll have the part in your hand and you can start testing it, which is never heard of. It's like not even months before. Nowadays it's like 24 hours, and they can be really high performance, especially if the design is done right. You can produce really high performance parts and systems using 3D printing. And this is also very well suited for low volume production, and of course lightweight design. The reason you can produce lightweight design is you can combine a lot of um, parts into one. Say, for example, imagine if you look at this disk, right? The turbine. In the traditional manufacturing, this is not manufactured as one piece. It's usually these are manufactured separately, and then they are assembled to the root, and then the root is welded to maybe a titanium and so on. So there are hundreds of manufacturing steps and 100 ways to go wrong, or introduce a defect. But you can just combine all of that and build one integrated part, including your cooling channels here. Okay, and this would come out of one printing shift. And this is how we can integrate a lot of different parts and make them really efficient and really lightweight and really high performance. Same thing, maybe this is like example of a heat transfer, what do you call it, a unit. And again, this is all printed as one unit, and it will really shrink the size. Not only shrink the size, it will basically, it's just one part instead of 100 different parts welded together or assembled together. This is again another manifold and so on. So from the perspective point of view of performance and lightweight, this is like amazing solution or amazing technology that we are now adopting in our design. And this is another big factor why people are also pushing for 3D printing is the aesthetics. The kind of three-dimensional surfaces that you can print is phenomenal. There is no other technology that even comes close. And for really high-end products, this becomes really, really important. And and designers are taking advantage of this feature, and they're building amazing designs and products. With respect to product cycle, this is very important in my opinion. What's happening is, if you have a motorbike, like I have my motorbike which is like 30 years old, and I don't even get any parts for that. Okay, so I'm like always trying to keep two engines spares, so that if something breaks, I have a part. But imagine hundreds and thousands of such vehicles going out of use because some part was not available because it's old, right? 3D printing you can just print one part that has failed and use it on your car. So it enables uh, legacy systems to continue to operate. And also, you don't need to keep this as a spare part. Like, if you nobody wants to keep a part for 30 years, right? Because production stops maybe 25 years ago, and all the production has to happen, and they have to continue to keep that for several years, so that when the part is needed, they can then sell it. So there is a huge storing and production and logistics cost involved when as the parts or the machineries become old, and there is a huge cost involved in repairing them, finding their spare parts, and so on. With 3D printing, you can completely get rid of that problem. You can print whatever you want and keep using it for however long it can perform. Huge benefit. And some of the advantages I want to touch upon is minimum wastage of material, um, really efficient that way. And whatever is not printed, you can recycle it and print it later. And you can really do a just-in-time kind of operations. Flexibility, I already explained. You can stop what you're printing for the next shift and then print completely different thing. From automotive, you can go to aerospace, you can go to biomedical, whatever, whatever the need demands, you can configure your printer to just print that. And that's a flexibility to respond to the demand is a huge advantage in manufacturing. And the infrastructure wise, all you need is a small printer. So the cost of infrastructure is really low, which means setting up a factory and procuring the land and bulldozing it and not all that. So pollution wise, it's very well controlled. There is not much pollution, and everything is contained. um, when compared to casting foundries, this is like almost zero pollution. And also it enables local manufacturing, which means we bring as much as possible locally, and not have to ship a part across the world, like from China to United States or India. Everything can be locally manufactured. With respect to what are the opportunities that are coming up with 3D printing, one is it's a new technology. It brings a lot of advantages on its own, as I touched upon in my previous slides. And just to take advantage of those, like shrinking your parts, making them lightweight, creating high performance products, and product development, quick iterations, and so on, that itself is a big opportunity for companies. And in future, how do we increase the production rate? Right now, this is one of the bottleneck for 3D printing, is the printing time is slow. So people are trying to find new ways to print at a higher throughput. And that's one of the opportunity. If some researchers want to do some research in this area, this is a big opportunity. If you can find ways to increase the printing rate, okay, huge opportunity. And of course, lowering cost is always a opportunity for any type of applications. And this is again, new alloy development is another big opportunity if somebody is interested. There are all kinds of materials, right? Not everything is 3D printed right now, but slowly people are finding ways to print these different alloys. That's one. Second is they are also trying to find new ways where they can do a sintering and welding and melting and so on. So they're trying to combine multiple ways to 3D print, and Ally has to support those manufacturing techniques. So there is a huge development opportunity for developing alloys which are suitable for these kind of applications. And again, I mentioned right now the volume that we can print is limited, and printing bigger parts is another opportunity. So there will be a lot of R&D effort that will go on, into this, and making them even more energy efficient. And how do we recycle this part? Because with respect to being green and sustainable, um, people can also innovate with respect to materials which can be 3D printed, but at the end of their life, they can be brought back and recycled. And also there is an opportunity to build an ecosystem itself. For example, once 3D printing is done, it has to be post-processed. So there can be another opportunity for somebody to set up post-processing facilities, coating or painting, and assembly and so on. So right now we are getting everything from one place, right? Everything comes as an assembled unit. But when we bring manufacturing locally, there are a lot of other associated steps that also will come and be placed around this 3D printing facility, and that builds a system in itself. Okay.